Good morning, ladies and gentlemen. May I have your attention, please? Thank you. Raise your hand if you didn't get a red mark for today, the 18th of November. Let's get started right away. So you will have a nice chunk of time today to work and review for your Unit 3 test. Remember, that's next class. So for us, Friday will be your Unit 3 test. For B-Day students, that'll be Monday. Let's go ahead and get started. Last class, we saw that we could solve radical equations in general by adding, subtracting, multiplying, or dividing to isolate the radical on one side, and then raising both sides to an exponent to undo the radical. We can always do our reverse and undo for forward steps, right, to get our solving steps if we want a systematic strategy in which to solve. So these got a lot going on here, and so I think this will be a nice opportunity to review how we could use our forward steps, reversing and undoing them to generate our solving steps recipe. So let's go ahead and plug something in for x. If we're going to plug something in for x and evaluate, my forward steps would be first add 1, then take the square root, then times by -3, then add 4. And so if we look at our forward steps, right, that's how we evaluate the expression involving x on the left-hand side of the equation. That's plus x, plus 1, take the square root, times by -3, and lastly add 4. So to get my solving steps recipe, we'll reverse and undo those forward steps. The last thing we did in our evaluation forward steps was add 4. My first solving step will be subtract 4. Then divide by -3. What's going to undo square rooting, right? What's going to undo square rooting? Tyler?
Squaring.
Squaring. So we'll raise to the second power as my third solving step. And lastly, we'll undo that addition of 1 by subtraction. All right, let's go ahead and take a look at our solving steps recipe in red and now purposefully apply those in order to solve for x. Here we go. First step, -4. So we'll subtract 4 from both sides. Thank you for showing that. That will get my -3 root x plus 1 on the left equals, and 25 minus 4 is 21. Next, we'll divide both sides by -3. That'll isolate my radical. So dividing both sides by -3 gets my square root of x plus 1 alone on one side, and set equal to -7. How do I undo that square root, right? What will I do to undo that square root? Casey?
Square both sides.
Absolutely, thank you. So we can undo a radical with index 2 by raising both sides to the second power. So we'll go ahead and raise both sides to the second power. And when we do that, go gadget arm, we get that quantity x plus 1 out of the radical, right, where I can deal with it and now solve for x. On the right, we get -7 times -7 is positive 49. So we can finish it out with a subtraction. So it looks like my final answer, after subtracting 1 from both sides, my final solving step is x equals 48. Go ahead and raise your hand if you had the potential solution value 48 when you did your solving. Potential solution value 48, great. But remember, when we're solving a radical equation, we want to make sure that we're always checking that final answer, right, to make sure we haven't created an extraneous solution. We've seen that when we raise both sides to an exponent, right, that sometimes it can create an extraneous solution. And we talked about under what circumstances that happens. We'll review those after our check. So we'll go ahead and take that x equals 48, my potential solution value. Let's plug it into the original. In for x, and we can even use our green forward steps, right? Everybody, let's follow along. 48 plus 1, 49. Square root of 49? 7. 7 times a -3 is -21, and then plus 4. So does -21 plus 4 equal question mark 25? Does -21 plus 4 equal question mark 25? No, and so what happened here? Well, this is not a solution. In fact, it's what we call extraneous. It's an extraneous solution. That is a value that satisfies the last lines of our work, right, but does not satisfy the original equation. Therefore, it's not a solution at all. It's extraneous, and we need to label it as such. In fact, there are no real solutions for this. No real solutions. And that will be our answer. Okay, what I want you to do is go ahead and survey our work and go ahead and decide with your partner quietly, your brand new partner, go ahead and decide which line could we have foreseen extraneous solutions, no real solutions. Go ahead and look back through the work Go ahead and identify which line we could have foreseen that result.
What do we call you in the case? Oh,
Okay, go ahead and share with the class which line of work here, right? What color, which line of work here could we have foreseen there be no real solutions, right? So where could we have foreseen there be no real solution? Taylor and Aaron?
We said the red, not to make the root x plus 1 equals negative.
Absolutely, and why did you identify that one?
A square root of something can only be negative. Yeah, it can't be.
Absolutely, right? This even index radical, that square root has an invisible index of 2. It's an even radical. We know that no matter what we have inside of it, it'll never produce a negative output. And so that would be an indication that there's no real solution. After following through, we checked our potential x value 48 and saw that it did not satisfy the original. That's what we call an extraneous solution then, and there's no real solution. Now you can stop here. If you recognize that this is an even root set equal to a negative number, and that will never happen in the realm of real numbers, you can stop right here and say no real solution. However, you must then say why. You say that an even index radical will never produce a negative output. And so you'd still get your answer point for no real solution, but then you'd lose your work and extraneous solution point, right, on the test if you had continued out. And so you have to give a reason why you stopped. You can't just stop and say no real solution. You have to tell me why. Does that make sense? Otherwise, you can continue out just as we've done and show your work like this. Awesome. What questions do you guys have about number 1? Let's take a look at our second then. Our second, we try to throw all kinds of inverse operations. So again, let's go ahead and do our forward steps. If we were to plug in a variable value for x and evaluate the expression on the left-hand side, the first thing we would do is square it. Then we would subtract 9. Then we take the 4th root. Then we multiply by 2. Lastly, we add by 4. So by reversing these forward steps, we can create our solving steps recipe. Let's go ahead and check that out. My last forward step was plus 4. Subtracting 4 will kick off the party. Then we undo that multiplication by 2, by division by 2. How would we undo a 4th root? Go ahead and tell the class when I call on you. All right, how would we undo that 4th root? Luke? Raise to the 4th power. Good, thank you. Then undo subtraction by 9 with addition by 9. And lastly, we'd undo the squaring. Remember, we undo squaring by considering the positive and negative square root. That's an even integer exponent. So when we undo an even integer exponent, we have to be on the lookout for 2 solutions, one given by the positive, one given by the negative square root. All right, let's go ahead and apply them. Here we go. First solving step in red is subtract 4 from both sides. Thank you for showing that. There we go. Zip. That would get 2, 4th root of x squared minus 9 equals 4. Next solving step, divide both sides by 2. Divide both sides by 2 gets my 4th root alone. Now we're going to undo the radical by raising both sides to the 4th power. And I'll go ahead and show that on both sides with my parentheses here, to the 4th. To the 4th. That gets rid of the 4th root. And now I just have my x squared minus 9 inside. Set equal to, and I'll go to my half sheet. 2 to the 4th is 16. And we're almost done. Looks like add 9 to both sides. So x squared equals 25. And then take the positive and negative square root. If x squared equals blah, then x is given by the positive and negative square root of blah. In this case, blah was 25. Sometimes this will reduce, sometimes it won't, but either way I know there'll be two separate solutions then. One is the positive square root of 25, which is positive 5. One is the negative square root of 25, which is negative 5. And again, I'm wary, right? I'm going to check these potential solution values in the original before boxing them, because I know when we raise to that exponent, we could have introduced extraneous solutions. Those are values that satisfy the last few lines of work, but that do not satisfy the original, right? They're extraneous solutions and aren't solutions at all. Let's go ahead and check. Ready? I'll grab the negative 5. Negative 5 in for x, and we can follow our green solving steps to help out. Negative 5 quantity squared is positive 25. Minus 9 is 16. The 4th root of 16 is 2. 2 times 2 is 4. Does 4 plus 4 equal question mark 8? Well, does 4 plus 4 equal 8? Yes, it does. So 5 is in fact a solution. Oh, and we did that for -5. Both of which are going to satisfy the original because I'm going to square either 5 or -5. The result is a positive 25, and the rest is the same. Awesome. Go ahead and raise your hand if you had 5 and -5. So did you get both solutions, 5 and -5? That's awesome, you guys. Way to remember the positive and negative square root when you undo a squaring. Remember, if you're the one creating the radical, you're the one making the radical expression. To undo an even integer exponent, that's when you're going to have the two possible solutions. Versus if you're just evaluating an expression where they're given a radical, right, then that's a single value in an evaluation. Great work. What questions do you have about today's solving Bellwork? All right, then we'll go ahead and take care of your homework number 8 check. I'm going to pause the recording when we check the answers, and then we'll resume to get our stamp count exercises. Okay, ladies and gentlemen, so today is going to consist of a two-part review assignment. On your Unit 3 Day 9 handout, you have a variety of in-class review problems where we'll have the answer keys posted, and you'll be able to check your work as you go through and review. You may work with a partner or individually, so long as the noise level is down, and have a chance to work and review in class with the in-class review assignment. Then the homework assignment is detailed on your purple assignment sheet, right? And so that is your regular review assignment, and I have answers for that I'll also post on the rear whiteboard. However, we want to make sure that you get credit for your stamps. And so, in just a minute, you're going to go ahead and begin your review assignment. But first, we're going to go ahead and get your stamp total for Unit 3. So what I'm going to do is leave this up for a little while. You can go through and find your Unit 3 Day 1 through Day 9 note sheets and count up your number of red marks out of 9. The activities, right, came from Day 1. Activity 1, properties of exponents, that was a whopping 10. And then our nth roots activity was out of 5 blue activity stamps for a total of 15 activity stamps. When combined with a possible 9 Bellwork red marks, brings your total Unit 3 stamp check to a possible 24. Now, if you were gone a day and didn't do the Bellwork, or you didn't get all of your nth root activity stamps, you might have 20 or 21. But there's a 24 possible. You're going to add your 2 red mark total and activity stamp total together as a single number and write that down on your Day 9 note sheet. I'll go ahead and stop the recording here and allow you to find your stamps. Thanks for doing that total first.